So today we're starting with inequalities. There's over lessons we did. Solving two-step equations or multi-step equations, I should say. Then there were solving literal equations, solving word problems, and solving equations with fractions. Now we're moving on to inequalities, and then we'll move on to absolute values and absolute value inequalities. So again, this one is a little bit difficult for me to exactly place because I don't want to skip over anything, but we did a whole lesson over inequalities already. I promised you, probably after this chapter, I'm going to assume that, I guess I should say, probably after this chapter, I'm not going to just assume you remember the stuff from our review chapter, because I'm not expecting you guys, when we do factoring next semester, I'm not going to be like, oh, well, we did that at the beginning of the year. No, I'll go over things and stuff, but this is one of those things that not only did most of you guys know how to do it before I even taught it, we have gone over this. So I'm not spending as much time on these first two types of problems, but I did put compound inequalities in here as well, which again, you should be familiar with. So I'm going to make sure we talk about that. We solved the second little problem. Just make sure that an equal sign is inequality. And the only time that that's going to make much difference with us is if we divide or multiply by a negative when we have to flip it. Other than that, we just treat it like an equal sign. So from here, just the problem, I'm going to distribute first. 3x minus 3, and nothing else changes. Make sure, this is probably obvious by now, make sure you're writing your inequality symbol fairly clean. I have some people that have missed this because they think that that's a 7, something like that, so be careful with that. So now I'm going to combine my terms because I have a -3 and a 2, -3 and a positive 2. And remember, those are right next to each other, or I should say, those are on the same side of the inequality. So we just combine those. I don't add 3 to both of those to get 5. It's just -3 plus 2. You can put that in your calculator. And now we can start canceling. Now again, for me personally, I like to add the 3 to both sides. If you don't, that's fine. You just might end up dividing by a negative. I don't like to divide by a negative. I forget that all the time. And so that's the way I like to do it. But again, there's other ways to do it that aren't wrong at all. X plus 3x is positive 2x. 10, I did negative 12 is less than 2x, less than by 2. I get -6 is less than x. So this is the double-edged sword. I like to keep my x's positive so I don't have to flip my sign. However, in doing that, I end up with the x on the other side. I don't know which one you guys would rather do. Some of you guys, you always remember to flip your inequality, but then if your x is on the wrong side, you actually graph the wrong way. Or if you're like me, I forget sometimes when I divide by a negative that I have to flip my sign, but I always remember how to graph. So whichever you want to do is fine. Hopefully you remember which those are. Then to graph this, I have a -6. It's an open circle. Now again, like this, obviously that's fine. Some of you guys, I would recommend rewriting it the other way. Just make sure you remember, this is saying that -6 is bigger than x. I think a lot of students try to remember that they flip it and then have to flip side and they remember it like that. And I think it's way easier to think of. If -6 is smaller than x, that means x has to be bigger than -6. That's what that means. If I'm bigger than you, obviously that means you're smaller than me. So then the equality x is greater than -6. Again, just think of it as you're kind of reading it backwards. So that means we are shading to the right. And again, we talked about earlier how that if x is bigger than -6, you're just shading the bigger numbers. And the bigger numbers. A longer problem, and you'll never hear me say that was an easy problem, but I will say the hard part, or I should say the new parts of that problem, aren't too bad. The hardest part of that is the stuff we've been doing with solving. And like I said, there's a lot of steps to it, and there's kind of a lot going on. I get it. But that's stuff that you guys, I said it last week, you guys should be getting pretty good at it because we've done a lot of solving already. And we're going to do a lot of solving this whole year. Next one, remember, if you have a minus in front of your parenthesis, you can treat it as a -1. That makes you feel better if that makes it easier for you. So we distribute that. -1 times +1 is -1. -1 times -5 is positive 5x. Then again, combine your like terms. 8 is greater than or equal to. 14 minus 1 is 13. And then start solving this two-step equation. Subtract 13. 8 minus 13 is 5. I believe -5 rather. Divide both sides by 5. So -1 is greater than or equal to x, which means x is smaller than or equal to -1, whichever way you want to say it. Now, I didn't say this last time, and most of you guys already know this. Again, we've done this already. But remember, the reason this is an open circle is because there's no line under it. There's no equal to part. So we're shading all the things that make this true. Well, if it's equal to -6, that's not true because it doesn't have that line. That's why I leave it open. This does have that line under it, so make sure you fill it in. And it's less to the left. Yeah. Are you talking about right here why they switched the sign? Oh, why did I not switch the sign? So I didn't switch the sign right here. Oh, right. So this is a positive. I'm positive 5, so it stays the same. But then the order is I switched this because right now. Okay, so you didn't put that on this step. You switch the order, so you put the 5x on the left. And so this is the spot where you should have put your sign because the x is on the left, right? People do. I'm glad you mentioned this. So when he went to this step, he wrote it over here. But when he did that, he put the 5x on the other side and then -5 and he flipped this. So that is, I should maybe mention that, that's the only downside to inequalities versus equal. With equal, you can always switch which order it was, what was on the left and what was on the right. On inequality, you have to be careful, make sure it's always the same, because if you ever switch it, that's fine, but you have to switch your inequality as well. So if you could have done that, where you switched them and rewrote it, that's fine, as long as then you remember you have to make your inequality. Thank you for asking. Okay. Any questions? Yes. No. Anything else? Should have thought of that. Next one is, and again, we did a little bit of this solving to get to this point. So this is the stuff that we did when we did our review chapter, where I already had it set up for you guys. And so we did the same thing with the equal sign. So what I already had set up is when you had a problem look like this, where you had 10 is less than 13, or 5 is greater than 2, or something like that, where there are no x's. And remember when we did this, I said, same thing with equals, when we did the review, I said eventually we'll talk about how we're getting to this point, but I wanted to just kind of give you a little baby step on how to finish that, or how to do those problems. So that's what we're doing. The variables will cancel. Now, we just did this not too long ago with equal sign, and the only thing I will tell you is it is a little bit trickier. You just have to, it's not It's not harder in the fact of the math isn't any harder. The math is all the same. It's harder in the fact you have to pay very close attention to your answer when you're saying if it's true or false. So the same thing. All these are going to end up where if it's true, and if it's a false, it's no solution. You just have to be careful with that. So this first one, x from both sides. Again, it cancels all, but it also cancels all the. So this is the perfect where all the variables cancel. So all I have left is 12 is less than 1. Sorry, negative 12 is less than 1. This is where you sit back and ask if it's true or false. An equal sign, it says if it was an equal sign, it's always easy. If the numbers are the same, it's true. If the numbers are different, it's false. But with this one, you have to think of it a little harder than that because it's an inequality. Is negative 12 less than positive 1? Yeah, negative 12 is less than positive 1. Negatives are less than positives. So this one is true, which means it's all real numbers. So again, doing the math is all the same. Numbers, if it's false, it's no solution. That's all the same. The only difference is deciding if it's true or false. Nowadays, again, it's not hard, but you've got to make sure you're paying attention and do that, not going too quickly. So over here, obviously, I did the same thing because I wanted you guys to compare. So those cancel again. We have negative 12 is greater than positive 1. So the exact same answer, the only difference is that inequality. And that's what I'm talking about. Everything's done the same, except for now, negative 12 is not greater than positive 1. A negative will never be bigger than a positive. So that is false, which means no solution. You have to take an extra second to look at that and think about it. Now, in my opinion, number 5 and 6 are even more confusing, and you, again, have to take that second to make checking and thinking about it. So if I subtract 2x from both sides, just like before, they cancel. So all our variables cancel. Remember, this is when you look at this, when all your variables cancel. I've done this before where I teach this part, and then people start putting no solution on all the other problems, or like they'll hand in their homework, and every answer they have no solution. This only is happening when your variables cancel. I end up with 5 is less than or equal to 5. That's true or false? Well, it's true to part. 5 is equal to 5, so that was true. That fits in that scenario. So that again is true, which is all real numbers. I realized this after I printed it. There should be a 5 here. So if you want to put that in your notes. 2x plus 5 is less than 2x plus 5. Again, it should look like number 5. That's the whole idea. So we subtract 2x, just like we did before. Well, now we have 5 is less than 5. So we literally have the exact same answer, except we don't have that equal to part. In my opinion, the hardest one, and this is what I think a lot of students fall for. Because if it's an equal, they know it's up, they know this one's true. So if it was an equal sign, it would be true to all real numbers. But it's not an equal sign. In fact, it's not even equal to. No, equal to, but that's not what we're asking. We're asking if 5 is less than 5. So that is false. But that's one you have to be careful with. Any questions on those before we move on? All right, go ahead, do number 7 on your own. I'll give you guys a minute or two to do that. My work and my answer are up there. If you put no solution or if you put all the numbers, I understand what you're looking at. I did this on purpose to try to make sure you guys are paying attention. Because first off, when you add, or if you're subtracting to get it that right, the 8 on both sides, they do not cancel for this one. Again, I think they look like they cancel, and I honestly thought that they would until I started working on this. So since 1 plus and 1 minus, when you add it to both sides, or if you were to subtract it, you end up getting a 16 or negative 16 in it. They don't cancel each other. Both positive or they're not both negative. However, the 12s cancel each other, but that's okay. 12 minus 12 is just 0. That's not no solution because our variable didn't cancel. Problem because it's kind of a lot of people cancel the 8s, and so they put all. Also, a lot of people, when the 12s cancel, they think it's no solution. That's fine. It's just 0, and that's actually easier because 0 divided by 16 is just 0. All right, moving on to compound inequalities. Compound inequalities are harder in the fact that they're a little bit more work and they're a little bit more confusing. All the math is the same. You just kind of have two problems at once. Do anything I will say with number 8, I do know some students that like to do this. They just keep it like this and they subtract 1, but they do it from every side. 9, 19 minus 1 is 18. Then you divide everything, all three parts, the left, middle, and right by 3. If you want to do that, that's fine. That's how I was taught to do it. Honestly, if I was doing this on my own, that's how I would do it. However, the reason I don't teach that way is because with fail, I'm always going to get in students that subtract 1, and then they only do it to the left-hand side. So it says 9 is less than 3x is less than 19. And then when they divide by 3, they only do to the left-hand side. So this 19 didn't change at all, and that's wrong. So if you want to do it like that, where you leave it as one compound inequality, that's fine. You just have to make sure every time, instead of you have to do things to both sides of the equal sign, now there's essentially 2 equal signs, there's 2 inequalities. So if you subtract 1, you have to do it to all 3 parts, the left, the middle, and the right. And then when you divide by 3, you have to do it to the left, the middle, and the right. I always recommend to do this, and again, it takes a little bit more room, but I split it up into 2 equations. The place I split it up, this 3x plus 1 goes with both of them. So that 10 is less than 3x plus 1, and 3x plus 1 is less than 19. Another mistake with this one is that a lot of people put 10 is less than 3x, and then they put 1 is less than 19. And they split it up right here with this equal sign. That's not going to help you, especially you get 1 is less than 19, which is true, but that doesn't have anything to solve. So that whole thing in the middle, the 3x plus 1 goes with both. Less than 3x, both sides by 3. 3 is 3, less than x. Again, I personally put x is greater than 3. On the other side, I subtract 1, and then I solve this one. 3x is less than 18. Divided by 3, divided by 3. I get x is less than 6. Now, here's the thing I should have said at the beginning, and one of the reasons I didn't is because, again, you guys had this in algebra 1, so I'm thinking most of you guys know this, but you might not have remembered. So when you have a compound inequality, it's either an and problem or an or problem, which means it's either smaller than 4 and bigger than 6, or you could have an or problem where it's either smaller than 4 or bigger than 6. If you ever don't see the word, it's an and problem. So if you ever have one like this where it's all crunched together, we have 2 inequalities, that's always going to be an and problem. But if you're ever not sure, an and problem is the one that they can put the word and or they don't have to. But an or problem will always say or. So if it doesn't say or, it's going to be and. Because or problems, they always say the word or. Now, it's for 2 reasons. I should have said before. When you're done with your answer, please, please, please put the word and. This answer, there's a shortcut way. I've had teachers that do it differently. I think that's just adding more. Again, this is not necessarily the best notation, but it makes sense and it's correct. Another way you could do this is you could write it the same way we did with this answer, where we had 3 less than x is less than 6. Maybe we'll put it this way, but if I were you guys, again, my big thing is even if you're good at that, doing that extra step is opening yourself up to have one more step where you make a silly mistake. So I always put it this way, but if you leave it this way, where you have this one and this one, you need to put the word and. So I know it's not a or problem. That's the biggest thing that people miss all the time. I can tell students, if you want, you know it's going to be an and problem. If you put the word and at the top and then you forget to do it at the bottom, I'll give you credit for that. Because all I need to know is I need to know that you know it's an and problem. That's the only thing I'm checking. So the other thing with and is the word and is where they overlap. If I say it's blue and green, that means whatever I'm talking about has two colors. It's blue and green, or maybe it's mixed where it's a blue-green color. But if I say my car is blue or green, well, that means it's one color or the other. It's not going to be both. That's the difference. And is where they overlap. So the best way to graph this, and I'm going to give myself a little bit more space, so we'll put this over here. I'll wait a second. It all depends on how you want to do this. This is, I put my 3 and my 6. Obviously, the 3 is plus, so that goes on the left. I shade each of these, but before I shade them, I kind of shade them above this one a little bit. Now, you can do it. I've done this before where I used to print out the 2 extra lines that I made you guys. I did 2 lines up here graph, and then I had this one as your final graph. If you want to do that, by all means, you can. But I this way, if x is greater than 3, that means I have an open circle at 3, and I shade to the right. And I'm not doing it on my graph because this is going to be where my answer is. But it's a really quick, easy way where I can see what that means. It's at 3 to the right. And 6. And 6, so it's an open circle at 6, and it's shaded. I just do that a little bit below that one. Now your final answer, just like I say the word and, it means where they overlap. Both of them where their 2 lines are, where they're both shaded. So since 3 is shaded to the right, 6 is shaded to the left, everything in the middle here, both of those shades. Everything in the middle is both of them. Another word to think, another way to think of and, it's the word both. It's both bigger than 3 and smaller than 6. Final shading, the 3 and the 6 are both open, and everything is shaded in between. I'm going to give you guys a little cheat code, and I shouldn't. I should be a good math teacher and not tell you this. But most of our problems that are and problems are going to be graphed like that. So if you ever have an and problem and you graph like that, you might miss one. If you don't graph like that for and problems, you're going to miss a bunch. So most of you guys are going to be fine. You'll pay attention enough that you can tell the difference. But if you ever aren't sure if it's an and problem, I would shade in between those because that's usually where those end up. We'll talk about that a little bit later once we get there. Maybe. I don't know if I go over that at all this year. Any questions on that one? Now again, it's in my opinion, it is difficult than the ones we just did earlier today. But it's not that bad. It's just we have 2 problems in one. I had to solve one here and one here. And then the other thing is making sure you remember the rules with and or, where the and problems is where they overlap. Okay. So let's go back to number 9, or let's go. They have, it's a compound inequality where it's all kind of squished together, so it's an and problem. So again, if you just put and at the top here, put it on your paper after that, you'll still get credit. And, bad idea. But I always split this up. So I have 5 is less than 4 minus x. 4 minus x is less than 10, and it's an and problem. Next problem, subtract 5 minus 4 is 1. Now we have divide by -1, you have to flip your sign. So now I end up with -1. 1 divided by -1 is -1. Then flip your sign, positive x. So again, I like to put it where the x is on the left. Then the other one, same thing, subtract 4. I get negative x is less than 6, divided by -1. We end up getting x is greater than negative 6. Now again, I like to put the word and in there. And again, the other way to put your answer, and this is again why I don't necessarily stress this way. Negative 6 is less than x, which is less than negative 1. So again, I think that's confusing. I mean, it makes sense if you think about it. And this way is a little bit easier because you kind of put it together. But since we switched our inequalities, it makes this one a little harder to write like that. So again, I mean, that's great. I would definitely, if I were you, I would leave it like this if at all possible. So graphing this, first off, make sure you realize negative 6 is smaller than negative 1. That's a big mistake with this one. Now we have that x is bigger than negative 6, so it's open circle and it's bigger. And x is smaller than negative 1, so it's an open circle and it's smaller. And again, our final answer then is where they overlap, so we're going to overlap in between. Now again, I'll say most of the and problems are like that. You don't want to get in the habit of doing that for all of them and not looking at it, because some of them don't. But most and problems are like that, which shade in between your two numbers. But again, this one, a really common mistake with this one is they put the negative 1 on the left and the 6 on the right. And then they shade in the middle, and that's not right. I mean, the shading part, I guess you could say is right. But you could catch yourself, I think, if you actually looked at where you graphed that. And the next one, number 10. So far, so good on these and problems. All right. So the next one is an or problem. So again, remember I said the analogy with my car where I said my car is green and red? Or where I say blue and green, whatever I said. If I say and, you know, oh, well, that must mean his car is two colors because it's both. It's green and red. The word or, if I say my car is green or red, well, now all of a sudden it's one or the other. It's not going to be both of them. So that's the difference with or. Like I said, they put the word or, so the two equations I already made for you. Let's solve. 7b is equal to 7b. Divided by 7 divided by 7. B is greater than or equal to 10. On the other side, 2. 3b greater than or equal to 0. We divide by negative 3, so I get 0 divided by negative 3 is 0, but we divided by negative still, so we have to switch ourselves. And put the word or here. I know some students say they shouldn't have to because it says the word or up here, but I like that in your answer where I can see that. And same graphing as before. We have our 0 and our 10. So we are doing v is greater than 10, so it's filled in. And you shade to the right. And v is less than or equal to 0, so it's filled in and shade to the left. The problem, it was where they overlap. They don't overlap. So if this was a problem, there'd be no solution. How about that in a second? No problem. So we're saying it's either or. It's either smaller than 0 or greater than negative 10. So your final answer, you just put both of those on the same graph. So just drop them straight down. That's your final answer. Now again, most of the time, not all the time, but most of the time, or problems are like that where they shade away from each other. Most of the time, or problems shade away from each other. I always say you can kind of remember it because if you're paddling a boat and your boat has oars, kind of looks the same way where your oars stick out from both ends. You're in the middle trying to paddle it. Maybe that doesn't make sense. Maybe you guys don't row boats. All right, go ahead, do the you-do problem. There are 2 of them there, and then we'll move on to those special cases quick. Like I said, we'll just see if we have time to get to our quizzes today. If not, we'll do it tomorrow. All right, my answers are up there. We're only about 5 minutes left, so I'm going to hurry you on a little bit. We'll be able to finish or we'll be able to get the next part. We'll talk about it a little bit. Thanks for those. Again, just make sure you're paying attention to see if it's an and problem or problem, and please include that in your answers. And then make sure you're being careful where you're shooting. Number 11, there was a spot where you had to switch your sign when we divided by -10, so be careful with that. 12 didn't look like we had that at all. Okay. Oh, perfect. So moving along, the next thing we have is special case compound inequalities. So again, no solution or all real numbers. That's what our special cases are. It's not always going to be like that forever in math, but for our purposes, but for the most part, the whole class, if it's a special case, for right now, it's either all real numbers or no solution. We haven't gone over any other options. Now, the other thing I have with this one for you guys is I have to solve. I didn't make it where you had to solve these, and I think that's how I'm going to stick to it because I don't want to make you guys do more work than you have to, I guess. So 13, I'm going to split that up just like we did before. So I have 10 is less than x, and x is less than 3. And I like to separate that 10 so it's on the right-hand side. Look what happens when you graph this. And this is what you have to pay attention to. I think I don't remember how it happened in the homework. You have to pay attention to when you're solving like this, so be careful. But we have my 3 and my 10. If x is smaller than 3, if x is greater than 10. Now, we'll graph that. There won't be anything of it because if it was an OR problem, this would be perfect. It's a typical OR problem with the shading, but it's not OR. This is an AND problem, so we have to shade where they overlap. If there is no overlap, there is no solution. That'd be like if I said, I will give you an A+ in this class if you can list me a number that is bigger than 10, and it also has to be, not only is it bigger than 10, but it also has to be smaller than 3. That doesn't make sense. There's no numbers that are both. Same thing with this OR problem. We have a 5 and a 12. Or similar with this OR problem. The 5 we shade to the right, or we shade to the left. Now the difference is with the OR, we don't shade where it overlaps. We kind of just shade, we just put both the graphs on one graph. So this one, all of them are shaded. So this is all real numbers. And again, that one's like if I said, give me a number that is, what is the number that is, it's either bigger than 5 or it could be smaller than 12. Well, that's every number. Every number is either bigger than 5 or smaller than 12. So that's where that all real numbers come from. So again, I don't remember what the test looks like. That will show up. They don't look like that. They're not solved for you. There's problems that are more like numbers 11 and 12 that you have to solve. And when you're solving the graphing part, that's when you'll realize it's no solution to all real numbers. So make sure you don't just get stuck in the rut where if it's an AND problem, you shade in between, and an OR problem, you shade away. Always double check that for that reason. The homework check is on Canvas or on Google Classroom, and your worksheet you have, make sure you're doing those.